Good morning, everybody. That's the first day of the conference. I'm sure you can do better than that. Good morning, everybody. Love it. So, very excited to be here. Thanks for having me here, Will, and the Lucene Revolution team. So as Will said, I am Sridhar Sudarsan. Just by a quick way of introduction, every day I spend time with a lot of our customers, a lot of partners, working within our own IBM teams, trying to dream up cognitive applications. It is fun, and I've been doing this for a few years now. And I tell you, it is fascinating. It's better than anything that I've done in the past, 15 years. From a technology perspective, it is really an incredible experience. So I'll take the next 30 or 40 minutes here to share some of the things that we're doing within IBM Watson, some of where we're seeing the trends that we're seeing, why this is getting to be more important. I know some of this you obviously realize. That's why you're all here, and we're going to share a little bit about kind of what we're doing within these Watson services, and how we're actually where we're seeing these technologies going forward. So before I go forward, I do have one special guest who also wants to say hello.
Hello, I am Watson. Good morning, all the Lucene and Solr revolution participants. I think that this open source community is serious stuff, but let's tickle your funny bone first. I've heard that a computer's attention span is as long as its power cord. But hey, a computer scientist is someone who fixes things that aren't broken. Adding manpower to a late software project makes it later. In this day and age, any program that runs right is obsolete. Hope that gave you a chuckle. On a more serious note, we'll now talk about data, information retrieval, and cognitive computing. Thank you.
So that was Watson. And essentially, like Will was saying, I used what we have called our speech-to-text service on Bluemix, and you're all welcome to go play with it as well. And I thought it'd be a really nice welcome here from Watson. So let's start sort of with a little bit of a step back and understand kind of why are we thinking about this as being truly a disruption. If you look back in the last 4, 5, 10 years even, there are just some companies that are just changing the way we think. There are technology innovations that are coming up that is changing the way we understand and explore information, if you will, right? And if you look at some of these companies that you're probably very familiar with, Uber does not own any cars, right? Don't own any taxis. Airbnb does not own any real estate, but that's what they do, is they deal in real estate. Alibaba does not have any inventory. It's one of the largest retailers, if you will. So what does this really say? The point here is that information is everywhere, right? Data is really ubiquitous. As you've probably heard, it is really the new natural resource almost, or maybe it is a resource after oil. It is kind of becoming to be really powerful. And I think what we're doing here, what we're all doing here, is really trying to extract the best out of that data and make it relevant. So if you look across industries, and I'm sure many of you have worked on applications, have worked on technologies that are supporting these applications, the amount of information that is continuing to be produced is just mind-boggling. It is truly mind-boggling. I mean, it is unfathomable. And these are just some examples. Like if you look at the number of sensors within an oil and gas facility producing 15 petabytes of data. I mean, we didn't even think about that a while ago, right? Public safety, if you look at cameras being put on in public areas, in roads, on roads, traffic signals, buildings, security information. I mean, the amount of data just being produced within New York City is 520 terabytes, right? Every single day. That's a lot of data. Now, the part that is very interesting is a lot of this data is unstructured. It's in unknown forms, more and more evolving forms as we start seeing new ways of actually generating this data, right? If you look at healthcare, there's X-ray images to medical journals to talks and conferences like these where researchers come together and talk about best practices. There's just data equivalent to millions of books that are being generated on a daily basis, right? And that's more data than we can probably consume in multiple lifetimes of our own. So as Will was describing, I really liked his trifecta chart because I think it is a very simple way of explaining the complex problem here. The fact that 90% of data was generated in the last couple of years really says that we're doubling data every year, or every 2-3 years now. The amount of data that will be uncertain in just 3 years, 4 years from now is 80%. So I think the way that we need to start thinking about these information retrieval systems that we're all building, technologies, whether it's open source, or applications that you're building, products you're building on top of these open source technologies to support these open source technologies, we'll really need to shift from what data we're consuming to how we're actually just continuing to build extensible systems that make sense of information that we don't even know exists today, right? And that's where some of the aspects of what we've been calling within IBM Watson, as within the Watson team, within IBM, as cognitive computing comes into play. So we'll talk a little bit about that. But if you, again, continue on that theme of disruption, there's really a proliferation of a large variety of different types of data, as we just saw, right? Being able to codify that data, being able to understand that data and make insights, make connections, whether it's enterprise data, whether it is public data, whether it's subscribed data, whether it is, there's the authorization aspects that come with it, there's the authentication aspects that come with it, right? And we've seen examples already, although they're fewer and far between, that they're not generally concerning in the general public. But as technologists, I'm sure you're all keeping track of the kinds of things that you're seeing. So this is where I strongly believe that technologies like cognitive computing starts truly playing a role, whether you call it intelligence that it brings in, whether you call it the ability where it starts understanding what information is being produced by other things in the IoT scenario, or if you think about information that we as human beings are generating, excuse me, whether it is as spoken text or as videos or pictures as we're creating every day. So, the number of devices that are now coming out with lines of code is just, millions of lines of code has become the new hundreds of thousands of lines of code, right? A car comes with 100 million lines of code, which is more than what is on a Boeing airplane, I think, which is about 60 million lines of code is in a Boeing 787. Which then opens up challenges about security hacks, and you've all seen the in the automobile scenario where there were there were incidents where somebody actually tried to remotely control a car that somebody was driving and didn't know what was going on and so on. So it just opens up a whole new aspect of technology areas that we need to start thinking about in terms of how we can start making sense of all this information in the right way, right? In a relevant manner. So as I mentioned, again, just something for us all to fathom here, the amount of unstructured information is really doubling almost every 2 years across industries. So it does not matter what industry you're working in, whether it's media and entertainment, healthcare, financial services, retail, manufacturing, automobile. Any of these industries you look at, they're all roughly in that scenario. And I think it's just going to grow even more exponentially. So, this is why we're all here, right? Is what do we do? What kinds of things can we do? So really, if you start looking at how we're looking across these different systems that are generating information, here's another example of how If you look at in the drug discovery scenario, there are just so many different factors that are playing a role, right? All the way from looking at genes and genetic modeling. If you look at chemical compounds and what plays together, how do these compounds play together? How do molecular information come together? If you look at sort of clinical trials that are being done, if you look at regulatory guidelines that you're getting from the FDA, from CDC, and other government organizations here in the US and worldwide, if you start taking all of these, I mean, just looking at this picture gives you an idea within one simple field, well, simple, but one field or one area, narrow area within a field of life sciences, how many different variety of information you're actually getting, right? And if you look at genetics sequencing, there are patterns. The patterns need to be discovered, and as humans, I don't think we're equipped to do that at scale, which is why we have technologies, which is why we have systems that are doing it now. But then really being able to make those correlations is really where the challenge lies. So switching to why do we think humans and computers are going to interact in different ways than we've generally thought about, right? I mean, we didn't really even think about how we interact with our mobile phones, with our watches, with wearable devices as just general human beings, the way that we do today. I mean, we probably didn't even think about that 15 years ago that we would be doing that now. So if you think about why do we believe, or where do we believe the sweet spots are for computer systems, for data, for information retrieval type systems, and the kinds of qualities that humans bring in, right? I know it's not something that you're worried about in general, but there is a question that always comes up about, well, is this really making humans irrelevant in this whole processing information scenario, if you will, right? And is human-to-human interaction really becoming irrelevant? And the point is, I don't believe so, because there are some things that we as human beings bring to the equation which is very different from the kinds of things that you get from systems, from machines, right? So if you think about the emotions, morals, ethics, dreaming, being able to just visualize things, being able to just generalize things, these are some of the things that we as humans bring into this mix. And I think combining that with some of the things that we've been talking about all along around how do you scale large systems of information is really where I think this partnership is going to grow, right? And I think as we all as developers, as technologists, as architects, really need to start thinking about, or continue thinking about, different ways of empowering this kind of an interaction, right? And I think that is really where you're going to start seeing more and more applications come up, more ways of user interfaces, user design, the ways of processing in the background, the way infrastructure scales accordingly. 50 billion devices are going to be connected in the Internet of Things in the next 5 years. Being able to consume these kind of structured, unstructured, semi-structured, sensory information, it really starts becoming relevant, right? And then not just consume, but then the next part of that is, well, how do I surface information? When do I surface information? Who do I surface information to? It is that relevancy which I think is becoming a critical part of how we need to look at things. So as we as IBM, as we start looking at a cognitive system, and obviously there's a lot of different characteristics in a cognitive system, right? You put yourself as a human being, and the way that we learn, the way that we grow, there are a lot of things we do where we don't even do it out of thinking, right? It's some of our muscle memory that gets built in, some of the things that we don't even think about, especially if you think about how you drive to work. If you drive to work every day, oftentimes you don't even notice, you don't even pay attention to the things that are going on because you're just sort of doing it, right? So things like that are some of the capabilities that we as human beings grow. And then of course there's perception, there's introspection, there's reflection, there's a lot of these these characteristics that we exhibit, and I'm just going to click through all this so you can actually see it, but we as human beings exhibit, which makes it very interesting to actually start combining those characteristics and bringing some of those characteristics into computing, into information systems. So if we look at sort of the broad set of the characteristics that we are looking at from a system and how do cognitive systems portray this, and there's still a lot of debate about what is cognitive, what is artificial intelligence, what is analytics, what is machine learning, and I think you'll find different schools of thoughts, different definitions. But really, the way that I look at it, if you're trying to sort of simplify the whole system, is without really getting too hung up on how or what you're actually using or what you're calling it, which I think over time, some of that will change, will evolve. But really, the key is about how do you take these large bodies of data, all kinds of data, and how do you make sense of it? How do you make sense of it? And then the third part of that is how do you surface it, whether it's to a human being, to another system, to an upstream or a downstream system, and then you do this sort of all over again, right? And then it's not just about what information you surface, but it's also about how you surface it, right? And the way that I would have a dialogue with a person who works for me would be very different from the way that I would have a dialogue with my wife or with my friend. And even if it is the same question that each of the three of them ask me, saying, what do you do every day, right? Or how do you spend your days at work? It might be a different answer. So it's coming from the same person, it's coming from the same kind of data that I have, but it's a different way of expressing what it is, right? And perhaps there is a rationale for it. There's, like I said, an emotional connection that you're making. There's a time of day that might be important. There's a lot of contextual relevance that starts coming in as well. So again, the basis of this is how do you look at underlying information? And it's not always about responding to something, right? It's not about asking a question and getting an answer. That's not what a dialogue always is. Sometimes a dialogue is about sharing information. So right now, for example, I was not asked a question, but I'm sharing information. The conversations you have in the hallway is about actually having a dialogue and being able to, as humans, we're pretty good at actually context switching too, right? Sometimes we are talking about one thread. It's never linear. It's not like you see websites which have point and click. You start with a superset and then you keep sort of filtering down. As humans, we're very non-linear. We're talking about one thing and then we suddenly switch context and we start thinking about something else. So being able to sort of process that interaction model is just as important as being able to surface the right results at the point of interaction, right? I think that becomes very critical. So like I said, being able to respond, to engage in a dialogue, to look at a large different variety of data types, of big data types, if you will. Being able to extract the right kind of entities, right? What is being said? What is the intent of what somebody is actually talking about, or is an utterance that is being made, or a piece of written text that exists somewhere? How do you make sense of that? How do you classify that? How do you then respond to that? How do you clarify information? These are all the types of things that we continue to build within IBM Watson, right? So if you ask me today, what does IBM Watson do? And what are we, so this is what, these are, as I said, the characteristics of a cognitive system. So within IBM Watson, essentially it is a platform today of a set of APIs and services that we provide to enable technologies that we just talked about, to enable these cognitive technologies so you can bring those within your applications as developers, as customers, as clients, as researchers, as academia. This is the space that we're trying to grow in, right? And it's really all about making it available as APIs so you can incorporate it in. There are some of these services that you can actually use to, that you do need to do supervised learning techniques, right? You do need to do an adaptation. Not all of these services are designed to work as is. I mean, they will, but then it's again about systems that need to be trained, right? That's where your machine learning models come in. That's where the way you build ontologies in some cases come in. And so along with all of these services, there are, at runtime, you also have tooling that helps some of them as needed. But the objective really is, as we're building these together, right, and we're building some of these on open source technologies, as Will said, IBM has been a very strong supporter of open source technologies. Some of these services are actually using Solr today. So being able to, and we use Lucene search. We actually have, I think, some of our committers here from IBM as well, who are part of our team. My colleagues are here from IBM. And it's all built on some of the technologies that we have here. So the idea is, these are really intended for developers like yourselves, so that we can build applications that will change lives, right? And as we talked about, within oil and gas, within media and entertainment, change the way we do banking, change the way we do healthcare. So that is kind of how we're thinking about IBM Watson. That is the platform that we have. And then of course, we have very specialized sort of industry-based, whether it's within the healthcare space or IoT space, that get built that really look at the full stack from data to sort of higher level, very use case driven applications, right? But really at the core of it all is understanding information, making sense of information, making sense of interactions. And I was talking to somebody yesterday in the hall. User experience is a very important part of systems that we're building today. And the reason for that is because the way we interact with systems is changing. It's not always about having a programmable system. Now, it's not always about having a programmable system that says, if this, then do that, or here are sort of certain conditions, and you always respond to these conditions in this way, right? That's how we've been used to 5 decades of programming, which I believe will still continue, right? I don't want but as we look at machine learning models, there is the notion where you're going to get an incorrect answer. It's just like human beings, right? Even if you pick an expert and you ask that's why you have the stump the chump session later today or tomorrow. I mean, there is a champion, but you might still stump them, and it's okay. There's nothing wrong with that. That's how we as human beings learn and grow and expand the kinds of things we're looking at. Systems were not like that, right? I mean, you know exactly when you can stump it because you know the kind of errors, because you know the kinds of programs that you have created, and so you know how to work around that. With machine learning, it's not quite like that. In fact, when we did the Jeopardy show, anybody here watched the Watson Jeopardy show 5 years ago? Yeah, so some of you. So when we did the Jeopardy show, we had no idea how the system's going to perform, how Watson was going to do. In fact, even 2 days ago, I think we only got about 58 or so % right, questions right. So honestly, it is one of those where it's like we all prepare for a test and go sit at a test, and we have no idea how we're going to do, right? Especially if it is an open-ended test. It's not one of those where, like a driving license test where you have 30 questions or 100 questions and you need to get 10 of them right or 25 of them right. But those are the kinds of things that we need to learn to adapt systems for, right? And I think that is something that end users don't quite get because they've come to expect systems. So if I go to my ATM machine and I say, I want to withdraw $100, I better get $100, right? I don't want the ATM machine to think that, you know what, your balance this month, you already withdrawn $700, so I'm not going to give you any money. So go figure, right? That might be what a machine learning model would be. If you have kids, if your kids come and ask you for $20 for something, you might very well say that response, right, as a human being. But if they have an ATM card, they know that if there is $100, they can get it all on day one, or they can spread it across 30 days. So there is still going to continue to be a need for having programmatic systems, but I think it's really all about bringing these kinds of adaptable machine learning models and systems together as well, right? So that's that's the piece, that's, I believe, is one of the key pieces of differentiation between a system that learns over time. And how it learns, again, is there are a number of different techniques of how systems learn, right? You have supervised models, you have unsupervised models, you have semi-supervised models. Even within each of these, there are different ways of how a system does reasoning and how you help the system to do reasoning, whether it's inductive reasoning, abductive reasoning, deductive reasoning, any kinds of reasoning model. So those are really some of the highest orders of learning within cognitive systems that we're continuing to work on. And honestly, I think we've been working on it for many years. The algorithm, some of the research work has existed for even longer than that. We're now seeing some of these come to the light of day. After the whole AI winter that occurred 30 years ago, right, or 40 years ago, we're now approaching it very differently. So I think there's going to be a lot higher chances of us succeeding, us collectively succeeding and elevating where these systems go. So anyway, so this is what, as I said, this is what IBM Watson is, and we are really committed to continuing to provide these underlying technologies, as I said, building on open source in some cases our own research. We contribute back to open source as well in many cases. So I think we'll continue to see that partnership evolve. And and now what I want to do is talk about sort of how we categorize. And there are different ways of categorizing. So far what we've seen is why is it important, what kinds of data exist, and you know that. We talked a little bit about what these cognitive systems and general characteristics are, and then how Watson is playing a role. And I did want to talk a little bit about kind of these 4 broad areas that we believe you can look at a cognitive system, or you can look at a system and apply different kinds of techniques to solve those problems. Exploration. So exploration is all about, like you say, like explorers of the past. They don't know what they're looking for, but they're out exploring to find something that is interesting. Very different class of problem than, for example, an engagement. An engagement is, think customer support scenarios, right? Think of how you engage with your cable service provider, or with your bank, or with your credit card company, or with your neighbor. And the engagement could be, short-term, very transactional. Hey, I have a problem with my bill, go fix it. Okay, here's how you fix it. Or it could be sort of a longer term where your cable company keeps sending you, marketing materials saying, hey, upgrade your service, get the faster internet, buy, more TV channels, and so on. So the life cycle of how these engagement processes deal with clients or people is also changing. Discovery is very interesting. So that problem that we saw about drug discovery or molecular, how do people come up with new recipes for food? All of these, molecular gastronomy, all of these are discovery problems, if you will, right? Where there is a lot of information, you kind of know what you're looking for, but you don't have a very specific question that you're expecting a very specific answer for, right? So cancer research is a good example of where it does include a lot of discovery problems in that space. And then decisioning is about making the best decision, knowing the kinds of information you know, within the context you know, at the time you need to make the decision, right? So if you think about what doctors do, if you think about what financial advisors do, if you think about what your insurance broker does, if you think about what your travel agent or your friends who are experts at restaurants, or if you think about what you do with applications that have reviews about various things, it's all about helping you to make a decision. So there's a lot of different types of sources you use. How do you actually surface some of those within a decisioning application? So these are, again, 4 sort of broad ways of looking at problems. And the reason they're different is because the techniques you apply for some of these are different, right? The kinds of problems, the way you solve these problems are different. And I mentioned user experience, and I think user experience is going to change quite a bit as well. We're already seeing that over the last few years fairly rapidly. It's not just about how I interact with an app right? You've already seen that we've moved to apps from browsers fairly seamlessly. We're going to start seeing conversations, and conversations not just with an app, like a voice to text, but with maybe a projector. Who knows, maybe five or a few Lucene revolutions from now, you might have a Watson there talking about, and presenting the whole situation, or giving you an entire session there. And it could be about where you could actually stump a computer system. In fact, I think a couple years ago, in that CBS 60 Minutes that you probably saw, there was actually a robot at a panel at South by Southwest earlier this year. It was very interesting. I mean, it is a manifestation. It shows you the movements and so on. And I've got a little fun clip. So there you see Pepper the robot on that second, on the top right corner. I have a little sort of demo here at the end for you guys as well on that. But it could be, think about cognitive systems in the wall. So as I'm walking, I have a thought. Today I have to take out my phone. If my phone has low battery, I have to remember it. I have to make a little post-it note. But as I'm walking, I'm thinking about things, and they get transformed into whatever exists, right? So this is where a lot of the infrastructural pieces come in as well. So think about, not just cloud-based infrastructure, but how do you scale infrastructure into things that, where you could have an embodiment of a cognitive system within a wall, within a room, within a house, within your car, within the chairs that you're sitting on, etc. Right, so that's where I think user experience becomes very important. And I think as you're building your applications, as you're building these technologies, think about what kinds of things they can be surfaced in. So, so again, real quick on this, we have about, so when we started with Jeopardy, we had like one single, it wasn't even an API at the time, but we had sort of the question and answer system, which really just understood factoid questions, and also was primarily trained on sort of general knowledge type data. But it was also one of those that, if you think about it really carefully, it was really cool, but it only could answer or understand questions that are about 10 to 12 words long, right? It could only give a response in a single word or a phrase, which is good enough for Jeopardy. If you think about domain modeling and adaptation for Jeopardy, that was good. But then as you go into domains like medical domains, if you go into ERP systems, the types of sequels, the type of questions, the type of a case, if you go to a doctor, you're not going to them with a single sentence question. You're going to them with 20 minutes of describing what is going on with you. If you're lucky, you get 20 minutes with your doctor, but you describe kind of what is going on with you. There's medical history, there are forms that you're filling out that describe what kinds of things have, your family history, your prior conditions, etc. So when the doctor is actually looking at that information, it is a lot of information. And then being able to come up with those decisions that he's coming up with or she's coming up with is a very different set of problems that you need to solve and think about, right? So what we've done today is we've got a list of about 24 or so services and APIs that are all available through the IBM platform as a service called Bluemix, where you can go register and start using them, playing with them, if you haven't already. But what I wanted to do here for the next 5, 10 minutes, 7 minutes or so is take you through a couple of simple examples. So I wanted to focus on zooming into one of the services we have called Retrieve and Rank, which today is built on Solr. And there are two components here. There's Retrieve and there's Rank. So if you think about a lot of these, essentially a number of services, and before I go switch, I did want to show you how you can actually connect various services into an application, into a different UI. But let me switch to a demonstration here real quick, if I may. And like I said, the purpose of this, besides having just services, can you guys see my screen? OK. So besides just having services, we also have starter kits. And it's really, again, just aids for developers, quick sort of accelerators, if you will. On some of these use a single service, some of these combine multiple services, but they're really solving a problem. So this was based on some work that we had done over the summer where, again, as I said, a service we have called Retrieve and Rank. The ranker part really starts allowing you to customize the results that you get from a retrieve, from a search that you perform, and based on the features that you think are really relevant, right? So that when you surface the results, you're training a ranker and you're actually surfacing what the results that you believe are relevant for an application that you're building, rather than having a more of a one-size-fit-all type solution. So I'm just going to show you kind of what we did on that. So as I said, this is, and by the way, all of this code is available. There's a few other starter kits here that exist as well. So let me see if I can launch this app. And essentially, this is a simple app where you can, what we did was we took Stack Exchange information, and you're probably all familiar with Stack Exchange. We took the travel community there just because something that people will understand as a whole. And we created an app that actually compares the results that we got from just a standard Solr out of the box versus when you do retrieve and rank to see the kind of lift you get in relevance of these results. And so I was just going to show you a couple of these real quick. So we just picked a question that says, what are the must-visit destinations for a first-time trip to Argentina, right? And I'm just picking a couple of these as examples. But here's what you see on the left is what you get with retrieve and rank with the custom scoring that we did. In this case, we scored it based on, you know how Stack Exchange has the upvotes and downvotes. So we just said if somebody has upvoted an answer, fairly or a higher number of times, that is an important feature because obviously people understand the response. And so that's why that was one of the examples of a feature that we ranked it on versus what we did with standard Solr. And so you can see that in this case, now it's not always that one is going to get the answer right and one is going to get the answer wrong. That's not the intent. The intent is really to show how you can tune the set of results that you're getting back from a set of search results and make it more relevant. If you think about it, that's what we've been talking about all this while. So you can actually expand it, and you can see what the answer looks like. You can see kind of what the specific answer is here, and you also see why we actually picked this result in this case, right? So I'm going to do just one more real quick question. Recently, we just opened up the borders to Cuba. So if I say, can I visit Cuba freely? Again, in one case, you got a response on Cuba and flying to Canada and somebody's personal experience. In another case, you got a different response. I think you can kind of figure out whether, in these couple of cases, certainly we're seeing the results that you tweaked with rankers and trained with rankers being better than what you get with just an out-of-the-box Solr. And like I said, I think this is not just the be-all and end-all. You can continue to tweak it, and you can, as you find more. The beauty of it is, as you understand the kinds of queries people are having with your system, you can tweak it and use it in a better way. You can train your ranker, continue to train your rankers, and establish the right relevance. So this is used more in a scenario where you have where you actually have a relevance or recall being more important than the precision of the response, right? When you think about search, that's sort of always a trade-off. In some cases, it's a trade-off, right? Whether in a scenario like a Jeopardy, or if I'm asking my bank as to, how many, what's the minimum balance I need in to waive the fees, monthly fees, that's more of a precise answer that I'm looking for, right? I'm not looking for a big general answer. But if I go to my my doctor and say, why am I getting headaches over the past 8 months? I don't know when I'm getting it. I'm not looking, well, I am looking for an exact answer, but I'm not expecting an exact answer, right? And it kind of could be one of those, here's what we've seen, and here's the results that we've seen. It could be one of these, we need to run these tests. So it's really more of a recall being more important than precision, if you will. So if we can switch back. So I'm going to run through this real quickly. It's really not as, the reason I wanted to bring it here was I took a case study that we had done, a couple of my colleagues, Lakshmi and Solr, had done recently around being able to define, take a project management problem, risk assessment within project management is important. So we're just looking at real quickly how they're applying this problem, right? So the problem is, how do I go do risk management within a project within a project that I'm working on? So they took, as a methodology, they applied 4 hills. figured out what the source information is, and this is just a life cycle, showing you a life cycle of an application solution. So looking at Project Management Institute, books, best practices, they ingested that kind of information. Trained Watson, as I said, there's different techniques they applied to the more frequently asked questions versus the more long tail questions, which is where it trained a ranker on. Based on the training that we did, we were able to see that we actually got some pretty good, pretty positive results. In this case, like I said, it was done for a very small set of intents, just for demonstration purposes and to showcase how the full life cycle goes. Then we trained the long tail questions on about 1,000 questions or so, about 400 documents, being able to determine, ran some tests. I think we saw some pretty good positive results. There were still some false negatives that we saw, but the idea was that you can take this content in unstructured data like books, well organized, or like communities where you have people contributing data and creating knowledge in almost real time, and start sort of ingesting that and using that within an application, in this case, like risk management, risk assessment. So, and then in the example that we talked about, they integrated it with Slack. So when a project manager is communicating with other project managers or people within the teams, they can start doing a better job of assessing where the project is, what kind of resources they're looking for. And really, there are a few other ideas that you can start applying. As you see, when you use some cognitive technologies, you certainly start seeing a lift that you get within the results. And that was really the idea, right? That was really the intent here. So what's next? Well, as I said, there's a lot of embodied cognition forms that we're looking at. We're looking at the various ways of understanding even more kinds of data, right? Power to see and analyze. There's projects that we have going on within research about understanding X-ray images and being able to extract and make some sense out of that, so that, again, it can be added back into the pool of this vast data pool that we're all analyzing, we're all building technologies to analyze. There's the humanoid interactions, right? We've got some architectures that we're building around how do we surface in these embodied cognitions. And then there's also the hardware side of how do you build hardware that is more and more tailored towards being able to address the kinds of computing we're talking about right now. So, I don't know if we have about, do we have 60 seconds or so for me to run through a video? Yes? Okay. So I was going to run through a video, and this was just to show you some of the cool things that we're working on. So if you've seen some Watson robotics, we have actually a lab in Austin where we're building a robot. And so take a look at some interaction.
Please introduce yourself.
Hello, my name is Noya. I am one of 6 robots working with the IBM Watson team. Feel free to ask me anything. Also, what do you think of my blue robotic body? Isn't it pretty?
It's very pretty. Is that your favorite color?
I really like the color magenta. My eyes turn magenta when I am thinking of an answer to a question. What's yours?
My favorite color is blue.
That's a nice color, but magenta is better. Would you like to ask anything else?
Do you have any talents?
I consider myself to be quite musically talented.
Can you sing us a song?
Have you heard the new one by Taylor Swift? 'Cause the player's gonna play, and the haters gonna hate. Baby, I'm just gonna shake. Shake it up.
I thought you said you were a good dancer.
Wait, just take a look at this.
Oppa Gangnam Style. Gangnam Style. Oppa Gangnam Style. Gangnam Style. Oppa Gangnam Style.
So anyway, just a lot of fun that we have, as you can see. So real quick to conclude, and I strongly believe in less than 10 years, we're going to start seeing these kind of cognitive systems, artificial intelligence systems, whatever you want to call it, to be where transaction processing is today. I think the kinds of changes that we're all bringing in is really fairly rapid, and some of it is being demanded by customers, some of it is coming from research that we're coming up with. The way that we think we can amplify human creativity and really change the game of how, as I see, we start interacting with systems as human beings is really going to become very powerful, right? And I think we're going to start establishing very transformational relationships between human beings and between a human and a machine. So again, with that, I want to thank you all for giving me the time here, and I think I'm going to hand it to Will, or do we have time for a question? No question? Okay, all right. So I'm going to hand it over to Will.